Something happens the moment an expectation locks in. Before you've acted, before anything external has changed, your nervous system has already begun constructing the version of reality you're about to experience. Not interpreting it, constructing it. I want you to hold that for a second, because if it's true, and the neuroscience says it is, then the problem most people are trying to solve isn't the problem that actually exists. Here's the number that made this concrete for me. Your brain receives approximately 11 million bits of sensory information every single second. Sound, light, spatial data, social signals, temperature, a continuous flood of raw input from the environment around you. Your conscious awareness processes roughly 50 bits of that per second, maybe 120 on the most generous estimate. So what determines which 50 bits make it through? Not your intentions, not your effort, not how much you want things to be different. The filter running that selection process is your expectation, your nervous system's existing predictions about what the world is likely to show you next, and that filter is set and running and shaping your perceptual reality right now, below the level where conscious thought begins, which means this. Two people can stand in the same room, face the same opportunity, have the same conversation, and their brains will deliver genuinely different versions of that event to their conscious minds. Not different interpretations of the same data, different data sets, constructed in advance, shaped by expectation before perception even begins. That's the mechanism this video is about. And once you see precisely how it operates, not as a metaphor, but as a mapped neurological process, the question of why changing your expectations is so difficult stops being frustrating. It becomes specific. And specific problems have specific solutions. Stay with this. Before getting into the framework, consider what this actually means in practice. Every decision you made today, who you approached, what you noticed, what felt possible, what felt pointless, was made using information that arrived pre-filtered. You didn't receive reality and then apply your expectations to it. Your expectations ran first, reality came second, already edited. That inversion is the key to everything that follows. In 2010, neuroscientist Friston formalized what is now known as the Predictive Processing Framework, a model that has since become one of the most influential theories in contemporary neuroscience. Its central claim restructures the entire conventional understanding of how perception works. The brain is not a passive receiver. It does not wait for sensory input to arrive and then form a perception. Instead, it continuously generates predictions, top-down hypotheses about what it expects to encounter, and sends those predictions forward to meet incoming sensory data. What actually arrives from the environment is then compared against the prediction. Only the mismatches, the prediction errors, get prioritized and escalated to conscious attention. Everything that confirms the prediction gets quietly suppressed. This is not theoretical abstraction. Rao and Ballard demonstrated predictive coding operating at the level of individual neurons in the visual cortex. The mechanism runs all the way down to cellular architecture. Now locate this against a specific neurological structure, the reticular activating system, the RAS. Situated in the brainstem, the RAS functions as the physical gating mechanism between those 11 million bits of incoming sensory data and the roughly 50 bits that reach conscious awareness. It decides, moment by moment, what gets escalated and what gets filtered out. And the RAS is primed by expectation. What the predictive system has learned to anticipate as relevant, threatening, or worth attending to biases the RAS toward routing confirming signals upward, while suppressing signals that contradict the existing model. The implication is precise and significant. When expectation shapes what you perceive, it is not influencing your attitude toward an experience. It is determining the upstream data set your conscious reasoning receives to work from. Attitude operates on information after it arrives. The predictive filter operates before it arrives. These are not the same intervention point. And that distinction is why so many attempts to change outcomes by changing attitude leave the underlying architecture completely untouched. In 1964, organizational psychologist Victor Vroom proposed expectancy theory to explain a puzzle in human motivation. Why people with equal ability and equal opportunity consistently produce unequal effort and unequal results. His answer: people act based not on what outcomes are actually available, but on what outcomes their expectation structure tells them are achievable. Maps with striking precision onto what predictive processing describes at the neurological level. When these two frameworks are placed alongside each other, a closed loop becomes visible. And this loop is the mechanism most discussions of expectation and reality never quite reach. Expectation primes the RAS filter. Feel that first step, not abstractly, but concretely. Right now, something in your environment is being routed away from your awareness because your predictive system has pre-classified it as irrelevant to what you expect to find. You will never know what it was. The RAS filter, shaped by expectation, shapes what information reaches conscious awareness. That filtered data set is what your conscious mind uses to assess what actions feel available and worthwhile. Actions selected from that filtered assessment produce outcomes that are congruent with the original expectation. Those outcomes feed back, confirming the expectation, tightening the filter, closing the loop. This is not a mindset problem. It is a systems architecture problem. And that distinction matters because mindset interventions and systems interventions require completely different approaches. Here is where this conversation typically loses scientific credibility. It drifts into metaphor and starts claiming more than the evidence supports. So let's be precise. The research does not show that expectation alters physical reality. What it shows, clearly replicably across multiple independent fields, is that expectation constructs perceptual reality. The data set your conscious mind receives is not a neutral recording of what exists in the environment. It is a prediction-shaped, RAS-filtered construction. That distinction produces measurable, observable consequences. In 2013, Drew, Vore and Wolf studied expert radiologists, trained specialists whose professional competence rests on precise visual detection. When their attention was primed toward a specific diagnostic target, a significant proportion failed to consciously register a clearly anomalous object on the same image. In one case, a superimposed gorilla image 48 times the size of the nodules they were searching for. Same image, same experts. Perceptual reality diverged based on what expectation had pre-authorized the RAS to surface. The anomaly existed, it simply never made it through the filter. And then there is this, which changes the scale of the problem entirely. Benedetti and colleagues, studying placebo neurochemistry in 2005, found that expectation of a treatment effect triggers measurable neurochemical changes before any treatment is administered. Dopamine release, opioid pathway activation. The body begins preparing biochemically for an outcome that has not yet occurred, which means the loop is not purely cognitive, it is biological. Expectation doesn't just filter what the mind notices. Under the right conditions, it alters the physiological environment in which perception occurs. The system runs deeper than thought. Meanwhile, Easterbrook's cue utilization theory, one of the most replicated findings in attention research, demonstrated in 1959 that heightened negative expectancy physically narrows the attentional field. The range of environmental cues a person can process contracts measurably. Under low expectancy, what gets described as missing opportunities is not a motivational failure. It is the nervous system, operating normally, routing a narrowed band of information to conscious awareness. The opportunity may be present. The filter is simply not authorized to surface it. The loop doesn't just confirm itself. It biologically and neurologically seals itself. When the predictive processing model and the RAS mechanism fully connected for me. When I traced it through Easterbrook's attentional narrowing and the radiologist data, something shifted in how I understood the effort people put into changing their outcomes. Because here is what that mapping implies. If your expectation architecture is running below the layer where conscious intention operates, then every hour spent working at the conscious layer alone, repeating different thoughts, constructing different narratives, visualizing different futures, is being applied to a system that doesn't take instructions from that level. It's not that the effort is wrong, It's that it's aimed at a door that doesn't open into the mechanism, and the real cost of that isn't wasted time. It's what happens when the effort fails and the conclusion drawn is that you failed, rather than that the approach was architecturally aimed at the wrong layer. That conclusion is itself an expectation, and it feeds straight back into the filter. The research on memory reconsolidation points to where the actual door is, and it's not where most people are looking. If you have genuinely tried to change your expectations, not casually but with real sustained effort, and found that your outcomes remained largely unchanged, that experience is not evidence of personal failure. It is evidence of a mechanism operating exactly as designed. Understanding why requires one more layer of the architecture. Memory reconsolidation, synthesized by Nader and Hart in 2009 from decades of neuroscientific research, revealed something that destabilized established models of how memory and learning work. Memories are not fixed recordings. Every time a memory is retrieved, it briefly enters an unstable, chemically labile state, a window during which the underlying neural structure can be modified before it restabilizes. Outside that window, the memory reconsolidates unchanged. It locks again. Expectation priors, the predictive structures that prime the RAS, are built on consolidated memory. They follow the same rule. They are modifiable. But the window is narrow, and it opens only when two conditions are simultaneously present. The expectation is actively firing, not just intellectually acknowledged, but neurologically live. And incoming data contradicts it with enough emotional salience to register as a genuine prediction error rather than background noise. This is where Burgon's expectancy violation theory becomes mechanistically precise. When reality violates a strongly held expectation, the cognitive system faces a binary response. Update the model or protect the model by rationalizing the violation as an exception. Which response fires depends almost entirely on the strength of the existing prior and the emotional intensity of the contradicting experience. A weakly held expectation updates relatively easily, but a strongly entrenched prior, the kind built over years of accumulating confirming experience, triggers rationalization first, automatically and without conscious involvement. The system protects its own model, and the rationalizations are not experienced as rationalizations. They feel like accurate assessments. That was just luck. They were only being kind. It won't last. This doesn't count. If you have ever achieved something unexpected and found yourself immediately discounting it, finding reasons why it doesn't really mean what it appears to mean, that is not self-sabotage in the motivational sense. That is a nervous system doing precisely what it was architecturally designed to do: maintain predictive model stability against single contradicting data points. The same mechanism that makes expert scientists resistant to paradigm shifts operates in personal expectation architecture. One anomaly is not sufficient to force a model update. The prior absorbs it. So what does actually modify an entrenched expectation prior? The reconsolidation research converges on three simultaneous conditions. The expectation must be actively firing, emotionally and neurologically live, not just intellectually present. The contradicting experience must carry sufficient salience, enough signal that the nervous system registers it as a genuine prediction error rather than dismissible noise. And the contradiction must arrive before rationalization has engaged, because once the protective reframe activates, the reconsolidation window closes without an update occurring. This is the precise description of why certain experiences, sometimes relatively small ones, permanently alter a person's expectation architecture in ways that years of deliberate conscious effort did not. It is not about the magnitude of the event. It is about its timing relative to the active state of the prior and the speed of the rationalization response. A well-timed contradiction, arriving while the expectation is fully live and before the protective mechanism engages, enters through the door that conscious intention cannot reach from the outside. What this means for confirmation bias is equally specific. Confirmation bias is not a reasoning flaw amenable to correction through awareness. It is the visible behavioral symptom of a predictive filter that has already completed its work upstream before reasoning begins. Telling someone to watch for their confirmation bias while leaving the expectation prior intact is addressing the smoke while the mechanism generating it continues operating unchanged. The conversation about expectations and reality has been conducted almost entirely at the wrong level, focused on the content of expectations, their positivity or negativity, their alignment or misalignment, their conscious intensity. But beneath the content sits the architecture, the predictive prior, the RAS filter, the reconsolidation window, the rationalization mechanism. The content is what expectation says. The architecture is how expectation runs, and changing what expectation says without addressing how it runs leaves the system intact. Two observers with genuinely different expectation architectures are not interpreting the same reality differently. They are receiving different data sets from the same environment, courtesy of two differently primed RAS filters, constructing two differently weighted perceptual worlds. That is not a metaphor. That is a description of what human perception demonstrably is. Reality does not bend to expectation, but the version of reality that your nervous system constructs, filters, and delivers to your conscious awareness, the only version you've ever actually had access to, is built through expectation, pre-filtered by expectation, and continuously reinforced by the outcomes that expectation shape perception and action reliably produce. The question was never whether you believe enough. It was never about the intensity of the wanting or the discipline of the thinking. The question is what your predictive architecture is currently authorized to notice, and what precise conditions would introduce a contradiction that arrives while the prior is live, carries enough salience to register as a genuine prediction error, and lands before the rationalization response closes the reconsolidation window. That is not a motivational question, it is a mechanistic one. And mechanistic questions have answers.